So when you say AI background, are you doing some research in AI now? Or you have gone through the courses?
For example, I have done some courses in AI, and right now I am working in deep learning in medical imaging.
Good. How about you, Anjali?
Sir, same. I had a course on AI.
Okay. A course on
Yes,
AI, but you're not.
I am also.
Okay. So there are a few more joining. You're on 12. So I would assume most of you don't know AI. And still, it is a lot of value for you, whatever information I share. The intention is to make sure those who do not have clear understanding of AI, machine learning, deep learning, data science, analytics, business analytics, optimization, the combination of it. So the topic is demystification. So I would like you to stay with me, and I'm sure even if you know something, at the end of the session, I'm sure you would have a better clarity on what you already know. If you don't know anything, still you would learn a lot out of this. Okay, if you know most of it, still you will get a different version of it. So just stay with me, and I'm just going to open my PPT. Give me 1 second. I hope you're able to see this, and let me just do the full screen. Are you able to see my screen?
Yes, sir. Your screen is visible.
I intentionally kept it full screen. It means I don't know. I'm not seeing you guys.
Sir, it is not going full screen. Maybe you will have to share your entire screen.
Okay, let me do that. Let me just share not just the window, but the whole screen. So I will ask the question the other way. Raise the hand if you don't have, or if you don't work currently on AI. Raise the hand. Okay. So 1, 2, 3. Okay, few of you are not currently working in AI. Okay, good. Now, are you able to see my 1 second? I know. Just want to open the right screen. Are you able to see the screen full now?
Yes, sir.
Okay, good. Again, so we can make this interactive as well. We are not having that many people, so that gives us the luxury to make it interactive. And you can unmute and speak and then immediately mute once you're done speaking. That way we can make it more interactive. So according to you, I mean, AI is loosely used everywhere and anywhere, right? So before we go deep on that, I would like to show few applications here. And as you walk into a mall, the door automatically opens. As you drive your car through the toll gate, the FASTag toll payment happens. And then as you tap the credit card on the machine, just the tap, and then you're able to pay. Which of these is part of AI? You can just say, unmute and say it's okay. Which of these is part of AI?
Sir, FASTag toll payment.
Okay. Any other answers?
Automatic door opener.
Okay. Any other answers? Okay. So the answer is none. There's no AI in any of them. An automatic door opener is an RFID sensor. It is sensing an object coming by sending a beam, and then the beam gets reflected. So if the beam gets blocked, means some object is coming in, so the door opens. So the circuit gets closed. So when the circuit gets closed, the door opens. Okay, fast tag toll payment is again in the concept of RFID, radio frequency ID. You would have a tag, and then you have a receiver. And when you swipe the tag, you are sending your ID, and then based on your ID, it is processing it. It is processing, your bank account is attached to that ID on the server, and then it's just deducting the amount from your bank or from your FASTag account. It's deducting the money. So toll payment, there's no AI here really. RFID, scanning an ID doesn't mean it is AI, okay? And tapping the credit card and pay is NFC. I mean, that shoppers wrongly call it as Wi-Fi. Does your card has Wi-Fi, that symbol that looks like Wi-Fi? It means near field communication. Again, it is just getting the data from your card. There's no AI in it. Your credit card data. The swipe information is there, the same information that you swipe, instead of swiping, you're tapping it. It gets transferred. Okay, there's no AI in it. Okay, so not everything that you see that can be done with RFID or NFC or any other technology is AI. Okay. Now, what is AI? Is for that we need to know what is intelligence. Intelligence is something that we acquire and apply. The definition of intelligence is acquire and then you apply. And so by that definition, most of the machine learning AI models that you come across, they're acquiring intelligence from the data, or they're acquiring information from the data, and then they're applying that knowledge, acquiring knowledge from the data, and then applying that acquired knowledge from the data on the unseen data. So intelligence by definition is the ability to acquire and apply knowledge. What is artificial intelligence? Artificial intelligence is you have the biological intelligence, all of us, all the species. Machines don't have that biological intelligence. They don't have a real brain in a skull. They don't have the biological neurons. Okay, that's why it's artificial intelligence. They're able to still, without having life in them. If you have life in the species is able to acquire and then apply that knowledge. But machines do not have life. They're still able to acquire and apply knowledge, and hence it's called artificial intelligence. That is not a biological intelligence, and hence artificial. This term is coined by John McCarthy in 1956 or so, when he called for a mathematical conference of a bunch of mathematicians. And at that time, they had conflict of some parallels within the domains of computer science, and such as expert systems and few others. And because they're competing for all these similar concepts, he wanted to give it a new name. So he called it Conference on Artificial Intelligence. And then he made the experts to come and be there for a few days to discuss and bring forward what any intelligence other than human intelligence, what machine intelligence can do. And that's the conference, the workshop he had with a bunch of mathematicians. So it started from there. So what is artificial intelligence? Artificial intelligence is a technology that makes previously difficult tasks that only human can do. A technology that makes machines and computers do the tasks that are previously very difficult for humans to do. Okay? and if you want to really explain artificial intelligence in 2 words, can you tell in 2 words, what is AI? AI in 2 words is mimicking human behavior. Mimicking human behavior is what AI does. Okay? And so let us look at what is AI in detail. Okay? If it is called AI, ideally, you don't want to have x plus y whole square equal to x square plus y square plus 2xy. Very deterministic. Formula is very clear, and anything that formulates that into a program, such things are just programs. You write plenty of such functions. There's no AI in it. If it has to be AI, it has to have any of these three. It has to have voice, okay, or speech. Let's call it speech. If it is not speech, it has to be NLP / language. Okay. If not language, it has to be vision. So either it is vision driven, or it is NLP driven, or language driven, or speech driven. So speech, language, vision. If it has to do with any of these three, then it's really true AI. Why? Why? Because the name itself is coined for mimicking human behavior. And we, as humans, we perceive the information through sensors, or natural sensors and senses, and then we process in our brain. And then there is request or perception versus response systems that we are naturally built. And can we replicate how our eyes perform? Can we replicate how our ears and mouth perform together? And how can we replicate the language that we use to speak and communicate? Can we have these tasks or the behavior that human does through a machine, right? You may also say the cognition or the cognitive capability in your mind, the processing that happens behind. Well, all the data that you collect has to do with these sensors. We don't have optic, big in AI, which is touch, and we don't have smell and taste. So even these senses also would come in. Humans can tell the taste of it. Human can smell the fragrance in the air. Humans can feel the touch. Touch is there, some progress, but other areas are still very rudimentary. So our human behavior is dependent on what we perceive the world as through these five senses. And two out of these five senses plus the language is something that we are trying to mimic. Well, you may say, if you're doing very deeper mathematical calculation in your mind, and AI is able to do it very quickly, that's fast computing. That is also loosely AI in terms of rule-based AI, but that is something that has been historically there, a computer performing mathematical tasks. And suddenly, why would AI get the attention if the complex mathematics is done by computers? So that is loosely called AI, but that is rule-based AI. And let's not worry about rule-based AI. Okay. And so if you look at this, speech, vision, language, and cognition, that defines the behavior of the human in general in a given environment. And if you look at, we are able to speak and we are able to listen. AI comes and play a big role here today. Deep learning makes a bigger impact in speech. And if you notice, all the deep fake has to do with Obama speaking. A fake Obama video is good that media entity openly said this is not real. But if the media did not say that, everyone would believe that it was real Obama. It is that realistic, right? Then for you to have that deep fakes again, you would have different voices. First, you need to have that text that needs to be spoken, text to speech. But you're not doing text to speech alone. You're doing text to a specific personal voice, specific person's voice, right? And then listening. So when you're trying to listen, you're doing voice to text conversion, speech to text conversion. And when you do that speech to text, you're doing ASR, automated speech recognition. And when the speech is getting recognized, that is what you call listening. And within the listening itself, you have utterances. You have smaller than utterances. You have very small units. If you play your audio of one word in the slow motion, and if you see that, if you plot these small morphemes You would know that. You would know that. How do you break a given utterance of a single word into small chunks of mini syllables, and then within syllables again you have much more smaller units. Again, there you would have AI coming into your play. It in ASR, AI has a bigger play. How do you convert a spoken word or utterance into something like a text? There also deep learning and AI have made a greater impact. In fact, what you perceive in computer vision as deep learning has started in reality in ASR, automated speech recognition, is where the whole deep learning journey started. So do not assume that computer vision is only dominant, but that's why the language people, they always try to say we are better than you in the computer vision world. But computer vision people will come and say, no, no, Sarvendriyanam Nainam Pradhanam, we are going to take care of giving greater sense of the environment with computer vision. And there's always a tussle between these two people sometimes. And that is one side of it. Then how do you read? How do you write? That is something to do with OCR side of it. OCR is how computers read. And for that also, you need to see the patterns in the image for that particular number character or alphabet character and try to see, hey, this is letter this letter is this, letter is this. And our ability, the AI's ability, using again deep learning, many a times deep learning is default, de facto and default. You're able to do OCR, advanced OCR. And again write. Then again, what you see and process is computer vision. And this is deep learning is deeply involved here. I mean to say the real AI that is driven by deep learning is involved heavily in seeing and processing. There's traditional computer vision, of course. Then if you look at this little girl, she's just getting up the stairs and then coming down. Means you're understanding your environment. This is cognition. Robotics is a good application for cognition. Even there, you can have some prediction that there is one more step above you, and then so within robotics, your understanding your environment can be also involved with reinforcement learning sometimes because you're understanding an unknown environment through trial and error. And seeing patterns in data is also part of cognition, and hence you may call it part of AI. I'm okay with it, seeing some patterns, but it don't call simplistic things like you have a small rule-based function and then calling that function, you say, hey, I'm doing AI. Don't do that. So if you're finding hidden patterns in data, fine, that is also AI. And understand and learn how the neurons in our brain works. Inspired by that, can you do the cognition? Can you do some learning of understanding of the information given to you, environment around you by some kind of information processing? That also you can call AI. Okay. And if you call a simple RFID AI, that's a blunder. Okay. So and if somebody calls it, you can correct. So now the next question is AI in daily life. I mean, AI in games versus AI in some kind of deep fakes, all the lab-based experiments, research-driven work is fine. But AI in the real world is the key. I mean, Raj is already working in the processing of radiology images using AI. That is real world. You're doing some kind of a disease prediction, disease prognosis. That is real world. Real world AI is better than having some gaming AI or AI for Facebook, wherein your Face ID is tagged. That is also okay, but where is the real use of that? And for you to do that, I mean, some of the examples that you can think of is if you have the Face ID on the iPhone, it is doing the identification of your face. Only you can open it. Somebody else cannot open it. So it's security for you. Your private data is there. Nobody can break into your phone. And how does that happen? Think of it. How does your iPhone scan your face and then every time it correctly recognizes only you? So there is obviously a trained neural net model that is on the device and then it is doing inference every time. Okay. And this is part of this big subject in the computer vision called face recognition. And there are a lot of models, templates, and deep face net, and then there are networks that are out there that are very popular. Then you're talking about in deep learning world, if you're doing something, either you put deep in the front, whatever the object it is, okay, deep object, or add net in the end, object net. This is a terminology standard being unofficially followed. So if you are having some kind of cyst analysis, okay, you can call it deep cyst, or cyst is something that could be cancerous or not. Some lump in the body somewhere, some groupism of some lump. You don't know whether it's cancerous or not, but you're using some kind of deep network to analyze it. So you can call it, a new paper can come called deep cyst. Okay, fine. Raj can come up with it, or he can name it as CystNet. These are the only two ways generally new papers get named after. So here, deep face is you are recognizing the face using deep learning, or using a network you're recognizing, so FaceNet. So this is conventional way of creating AI papers, especially in the deep learning world. Then Gmail automatically these days is replying via email to you. If you send an email, you have a smart reply recommendation coming from Gmail to you, even before you compose. It lets you complete the sentence. So what is the underlying mechanism here? Encoder decoder networks based on text. Okay. And if you have a new friend, a recommendation from LinkedIn for a new connect, or in any social media, if you have a recommendation coming from social media, hey, I think you may know him, versus you want to be friends with him, versus you may like this movie. The suggestions that come, the underlying mechanism has to do with collaborative filtering. It has to do with causal modeling. It has to do with recommendation engines that are broadly known as. Okay. And so that may not be necessarily supervised learning. Many times the recommendation engine works in the unsupervised setting. Okay. Mostly through clustering or any other techniques such as collaborative filtering. And when it comes to Google Maps, it will show you on the way first 1 kilometer green, but next half kilometer is red. It shows the traffic is slowing down. It will give you the estimate. So when you have such green red combinations, and it will suggest you which path is a better path from point A to point B. You have this path, there is a traffic jam, you have this path, this is the time, this is the time. So there is graphic neural nets involved. Or it is also known as, GCN, many times they call it. So either GNN or GCN. GCN is graphical convolution neurals, and then Uber driver, when you hail a taxi using your Uber app and Ola app, Uber itself uses transformer networks inside. There is something called deep ETA. So what makes Uber or Ola special is they're always on dot on the estimated time of arrival. How can they do that? Most of the times they're able to succeed, unless the driver intentionally delays and then he has his own way to do it. And then for business reasons, even though they come to know based on his practice of reporting, whether he reports on time, even though it takes 10 minutes, he will have a chai break and all of that come in 20 minutes. So they also track that. Assuming all those things are not there, our driver is fooling around the system to directly frustrate you or make you call him to come and say, ignore the Uber directly, I will work with you, kind of direct business. If driver is looking, ignore all those exceptions. In general, their deep ETA gives really, really accurate results on when would the driver will come, or when will you reach the destination. This estimated time of arrival, either of the director or to your destination. These things are done with transformer networks inside Uber servers. Then when you have applied for a new EMI because you want to buy a new laptop, bank has to give a loan and they want to evaluate your ability to pay and then repay the loan on EMIs. For that, you make an application and they do a bank credit decision. Of course, here this is just tabular data machine learning. So now you see AI in daily life, and on top of it, what is the underlying technical mechanism that happens here? Few examples I have cleared. And, and machine learning, for example, let us see a pipeline of a typical conversational agent. You're asking Alexa or Siri or Bixby or any other conversational agent out there. A conversational agent is a better name than a chatbot. Chatbot could be on the web, you go and then they have some FAQ automated, and then you ask a question. If it knows the question quickly, it will give you the predefined answer. So chatbot may be a low level one. A conversational agent is more robust, and then it will be really engaging you through real conversations. And if you really notice here, whatever you say is graphically represented in this form, and that speech is converted to text through what? How do you do speech to text? There is a name for this. Converting the speech to text is what? There's a name for it. Does anyone know? I already told you. This is part of one system. Can anyone say it? It's part of ASR, right? Automated speech recognition system. Okay, whatever you're saying, just want to make sure you're listening to me and I'm engaging you. So far, so good. Any inputs? Am I giving you easy information that you already know? You want me to speed up? I can speed up. Okay, that's good. I am not seeing the screen, so you have to unmute and say it. I am on the full screen, so I don't know what's happening on the Meet link.
Yes, sir. Your talk is very clear, so I think nobody is posting any questions.
Okay, good. So if you want me to go faster, I can go. I have much more richer, better content, but I don't want to go very fast. Whatever time we will be done, at that time we'll be closing. Don't worry. But I don't have to cover all of it also. So I will cover demystification of AI, but it could be much more details are there. Let's not worry about it. So let's understand a typical. Remember, I said AI. If it is anything to do with language, anything to do with speech, or vision, or cognition. So this has to do with language, speech, the combination. And if you see here, most of you may have seen computer vision, but this side of it, maybe you don't know enough of it. So what is happening here? You are first, whatever you say to Alexa, hey, find me the nearest McDonald's. And then when you say that, speech to text conversion happens. Now it translates the speech into text. Now the text is available. So that is what it is. What time? So the question could be different. What time does McDonald's close is the question. Okay. And there is something called natural language understanding. How humans understand, hey, there is subject, there is verb, there is predicate, there are adverbs. And so when you understand and then do the POS, and you are doing POS tagging. So what time does McDonald's? So what is subject? What is verb? What is adverb? All of that is called POS tagging. Okay, and when you have the POS tagging, that's part of natural language understanding, and you're really identifying what is each word, and you're understanding the grammar behind it, so you can make sense. Even machine also tries to break it down like that. Those POS tags are important. And from those POS tags also, you would also see what is the intent. Hey, what time does McDonald's close is what Raj can say. And somebody else can come and say, when does McDonald's close? And somebody else come and say, can you give me the closing time of McDonald's? If the framing of the text is different, but the intent is the same. The intent is you are capturing the information of the McDonald's, which is important, and you're talking about hours, and then you're talking about what hours, closing hours. So internally, the intent would have this kind of a classification of an intent and then breaking down that intent. This is, you're asking for some information. That is a type of the intent of the question. Question could be asked in many forms, many different forms, but the intent remains the same. You're asking for some information about McDonald's and the closing hours. That's all it is. That's the intent. And that intent extraction, intent classification is also done by machine learning and deep learning. So that is done once you understand the POS tags, and then you are understanding the intent. Once the intent is understood, now the dialogue management system on the server side in the Amazon cloud, if it is Alexa or whatever the Siri it is, the dialogue management system takes over. What is the dialogue management system? What is it doing? It is very complex. It is very complex because I should understand the context. My prayer question is, what does McDonald's, when does McDonald's close? And my next question is, will it be open tomorrow at 9 a.m.? When I say it, humans understand in the natural language, it means McDonald's. So this dialogue management would take care of the prayer interactions, and it knows here it means it is referring to McDonald's from the previous conversation it had with the user. So that qualification is very important for any conversational agent, because we use all these pronouns for the nouns. Those pronouns have to be correctly connected with the nouns. Okay. And that is part of dialogue management system. Not only that, I am asking every time for McDonald's because I like burgers of McDonald's, but my daughter may be asking for Pizza Hut pizza. So when we ask the same thing to Alexa, it should recognize my voice and ID me. I'm that user. So there must be information about me in this database. And it knows that every time I'm asking about anything to do with burgers, Burger King burger, McDonald's burger, some other burger, but it knows that my intent is on the burgers. My daughter's intent, always likes pizzas. So the likes of the different users change. It also needs to track. Objective of a conversational agent, not to get too many questions to ask. Minimize the number of questions asking. It is asking, but get the answers the user wants. So this is very important. It would store the previous conversations. Not only that, it would also store the different contexts of it in different applications. In the past dialogue systems, for this question, this answer, the user was happy, and it stores that historical data. So end of the day, it is able to find the right answer for your question using these three databases, and comes back to you and say it has identified the answers. McDonald's closes at 11 p.m. in the night. Now, if this information is there as the tokens, you need to convert that into language. So you add the necessary subjects and make it a sentence. McDonald's closes at 11. All of this, at each and every stage, there is machine learning involved most of the times. And then once you have the text in some chosen voice, you need to convert that to speech. At each and every step in each of these arrows, there is some kind of a deep learning, machine learning involved. Now you see, it's pipeline of AI models. It's not just one AI model, pipeline of AI models. I just would like to bring you that up to the speed. Now, what is machine? I mean, can you think? Can you say, hey, what is machine? What is machine?
From intuition, we can say that a machine is an object which is made by human beings, and they can perform different tasks which human beings tell them to.
True. But what is machine in general? What is machine?
Sir, machine is a combination of simple machine like badges, gears.
Okay, that is true. What else? What is machine? What else can be machine? A machine can be a bot. A machine could be a simple computer. A machine could be an algorithm. Okay. It could be code. It could be a robot. We are using machine for all of this. Okay. In different research papers, somebody call an algorithm as a machine. Somebody may call computer as a machine, robot as a machine, code as a machine. It has multiple variations, and all of that leads to machine. So machine is a generic word for all of this. And what is learning? Can somebody define learning? What do you mean by learning? See, if you talk to any professor in any IIT, okay, oh, there's no learning involved. Yeah, there is learning involved. What do you mean by that? When you take a business problem and say, hey, I think there's learning involved here. No, there's no learning involved. What do they mean by learning? There is a learning theory, information theory. There's a learning theory is a big topic, big subject. One Some of the courses are driven by learning theory in computer science. Some of these foundations are driven by learning theory and ERM. And empirical, what is ERM? You look it up. So all of that comes from learning theory. But what is learning here? What do you mean by learning? Can anybody say it? I mean, learning you already know. Machine learning, learning is used for or by the machine, right? So can everybody take a chance? What is learning here? So learning is maybe a better definition is given in the next slide. A computer program is said to learn from experience E. Okay, with respect to some class of tasks T and performance metrics P. If its performance at those tasks in T as measured by P improves with experience E, then you can say it is learning from experience. So what is learning? Is learning from experience. Okay, who is learning? The machine is learning. What is machine? A computer program. A machine is learning. Machine learning is a machine is learning from what? An experience. Where does that experience come from? Probably some data, some inputs. Okay, with respect to some kind of task. The task could be identify whether the picture has a male or female. That's the task. So if there is a model, that could be identify it's a black and white picture or a color picture. Identify the voice that you heard is a male voice or female voice. Identify the intent of the conversation that happened with Alexa, the person's user's intent is about ordering pizza. Some information intent, asking for information, not even ordering. He's asking for information. So identify, see, there are different tasks. We are giving different tasks. So for a set of tasks, and how do you measure? Okay, now I know a computer program has learned from the experience or data doing a task. But you need to have a way to measure its performance, that it is identifying that there is a male in the picture correctly. How do you measure? There must be a performance metric. And it's not enough. It should improve with more data. If you have trained a model with only 10 inputs versus 1,000 inputs, there should be difference in performance. As you give more data, it should learn better. So when all of this happens, then you say it is learning or machine learning. There's another definition for machine learning that is about, if you look at machine learning, it's just nothing but a bunch of algorithms. What is a bunch of algorithms that are used by the machines. Why? To realize and get better with experience, learn from data and get better with experience without programming. They are not explicitly programming to learn from data. In other words, they are not trying to understand if you have a spout or if you have a tail or if you have 4 legs, then you are a cat. No. They are not looking at a rule-based, okay. They are not necessarily doing some rule-based analysis or closed form learning. It is learning from the data. If you're learning from the data and not using very hard specific rules, that would explicitly make you program. If it is about specific rules, and you would identify a human in the olden days, how do you identify? You would look at the pixel densities, and then if pixels repeat, and then if in the face, all you have to do first, how do you identify a face? Guess. You don't have machine learning models. How do you identify a face if somebody is giving you pixel values of each of these pixels of a 256 by 256 face photo? How do you identify it? Think of it. How do you do it? All you have to do is find black areas, pixel values near 0. Find them. Means your hair and then your eyes and eyebrows or mustache. So when you find 2 replication of 2 round black spots, what does that mean? So for you to identify a face in the olden days, how did they do? They did the coding in such a way, some kind of a rules. Oh, identify the spots that have two circular black areas, close to black areas. And then if you find two such areas, okay, then they are eyes. Now you know eyes, then you know how to, okay, because you know you're hard coding. The area above the eyes is called eyebrows, that are another black sets. Then go all the way, and all the black thing on the top, or all the uniform thing that has the same texture as the rest of the face is gray hair, black hair, white hair, that is hair. What are you doing? You're applying rules here. That is not experience. That is not getting better with experience. That is not about realizing using data. There is some rule-based learning. That's some rule-based way of, very traditional way of doing programming. Here we are not doing such programming. You are just understanding the data intricacies. And then explicitly you are not doing what example I gave you. How do you identify eyes first, then eyebrows, then hair, then mouth, and all of that? Because you have that geometrical understanding. And here, machine learning, when it sees 1,000 faces, and then it recognizes that there is a face in the image, it is not doing this geometry. Rule-based geometrical learning, it is not doing. If it happens, then you don't really want to call it learning. That is some programming, some rule-based way of solving a problem of whether there is a face in the image or not. That's not true learning. Okay, you need to have data-driven experience. You need to have that experience coming from data. You need to have some kind of a performance metric to see whether you're really learning from the data or not. So there is no real programming happening, keep in mind. The program is what is generated. So interesting, right? In the traditional way of doing things, you are given inputs and then program, it gives you output. In the machine learning way, you're given inputs and outputs, it gives you the program. Program is nothing but the model. Okay. Now let's look at this. So think of it. Okay, now I will show you, I will give you a loan application. Okay. When I give you a loan application, what is the response you would get if I give you the loan application? The response you probably get if I show you the loan application is, well, should I approve the loan or not? Okay, don't approve. Okay. If I give you an advertisement, a banner, the response you get is whether you click the banner or not, right? Each is a task here. If I give you an audio clip, what kind of response you get? If I give you an audio clip, generally, what kind of response there is no one single response that is correct. If I give you an audio clip, what would be your response? You can unmute and speak. My response would be, if I give you an audio clip, okay, in the interest of time and in the interest of your silence, your response could be, you know what? I want to get the transcription of that audio. Or no, your response could be, I would like to know whether the voice in the audio clip is male or female. Male voice or female. See, your responses could be dime a dozen. Your input could be the same. So your machine learning is always about the task you do. You may use the same input, same image, but the task could be different because your ask could be different. You're asking for different things, so your task is different. So here, but if you look at it, all these examples, there is an application behind it. If a loan application is given, you are finding out whether the person repays the loan or not. So it's in the loan credit approval application. If there is a particular audio clip is given and then you're giving the text for it, it's nothing but ASR, speech recognition. If English sentence is given, you are getting a French sentence response, which means you're doing language translation. If a car camera and other sensors or their inputs are given, then you are getting a response of where the position of other cars in the front. Means this is applied in self-driving cars. So what you have to notice is A is the input, right? B is the response. The whole world in the AI, all the startups, all the industries across the world, you know what they are doing in the name of AI? They're just doing A to B. Mostly supervised learning, if you notice. All of this has to do with mostly supervised learning. All that, most of the applications, 90% of the applications in the world, including Raj's healthcare diagnostics or imaging applications that he does, or whatever, okay, any application that you look, it has to do with, there is input A, and then you're giving a response B. This A to B is what machine learning is doing these days. That's all. So we have miles to go. We are just doing A to B. We are doing supervised learning. What is A to B here? Supervised learning. So what is supervised learning? We will discuss in the next slides. But there is input and the output, both are given as part of the input data. And then you are doing, you're sent, it's because you have to learn from experience, right? And once you learn from experience, you have performance metric, right? And you get better with more data. So then you are able to identify, you're able to predict, you're able to predict the class, you're able to predict what is the object in the front, you're able to predict how far is the object in the front, you're able to predict whose photo is that, you're able to predict whose voice is that, you're able to predict whether a particular airline engine 3,000 feet away from Kolkata to Bhubaneswar flight, whether that particular machine engine part is going to fail or not, based on the sensory data that is given to the control center of GE machine. GE control center is constantly getting the sensory data from all the aeroplanes, and then they would sense that, okay, what is the propensity that it would fail this particular airline machine in the next 1 hour, 2 hours, 1 day, 10 days, 5 days. Preventive maintenance is part of it. So I would like you to not to come from theoretical courses that you have gone through. On your day-to-day life, if there is A and you are looking for B, can A to be done using machine learning? Can be done mostly, many a times A to B can be done using machine learning. Come from outside in, don't come from inside out. Okay. And this is what machine learning does really, right? Traditionally in programming, you're taking data and program, you give to the computer because you're explicitly doing a program, it gives the output. That is what the recognizing the face in the photo in the olden way, what you're given the image of the face, that your program is finding a way to find two black circles and calling them as, and then it will use that as the starting point, and then it navigates the entire face. That is what program is doing in the code. You call the eyes function, then you call the eyebrows function, all of that one by one. You identify, then you highlight, and then you label them, whatever. In the output, you would show, you would say, you know what, given image has 2 eyes, you will have the rules. If it has 2 eyes, if it has a nose, if it has a mouth, if it has 2 ears, well, you call that, yeah, this is face. But if you're just given a potato, no, you look at potato, it has multiple eyes, but they are not dark. I mean, they're light. I mean, and your rules would say, no, it's not a face, isn't it? So, but that is all program, hard-coded, very rigid, not flexible. That is not what you're doing machine learning. In machine learning, thousands of faces are given with saying thousands of faces, thousands of potatoes, thousands of something else, and say, hey, this is what I'm calling face. Hey, this is what I'm calling potato. Hey, this is what I'm calling a sack. Then computer is learning from the data using machine learning, data-driven learning, and then it's coming with a program. After the training is called model. Okay, so that's the big difference. Now the question here is, where do you apply such machine learning models? I would like to know, based on the last sales, based on how many downloads I had with Netflix, how many movies I have seen with Netflix. I would like to know at Netflix whether you're going to resubscribe next year or not. Churning is whether you leave me or not. If you're going to leave me, then I want to throw you a carrot. If my prediction that you would leave in the next 2 months, because at the end of your 1-year contract, because you have never downloaded any movies, why do you keep paying freely? Then I need to somehow send you a teaser. I will give you a carrot saying that the movie just got into OTT, everybody is paying 100 rupees, but you can watch it free as complimentary. You have been our good customer. I'm trying to make you happy. For that, I need to know first, are you, see, if I give to everybody who is leaving, then I'm losing more money. Freebies are costly. I only want to give to those I know mostly they have a chance to leave. Somebody is already burning all the movies on Netflix He wouldn't leave. Why should I give him 2 free more movies? I wouldn't want to give. I want to give those who are not using my service. So how do you know? How do you know a particular customer leaves or not? Based on the past history of people like him or her who left Netflix without a renewal, I would like to do contrast comparison. Now the time is 7:54. I probably have another 10 minutes. We started 4 minutes behind. My question to you is, do you have questions? Or I would use all the 8 minutes, 10 minutes to finish the few more slides. You have to speak. One of you have to speak. At least 3 of you have to speak. Then I can decide.
If anybody has any questions, they can just unmute and ask, sir.
Yeah. Okay.
Otherwise, sir, you can continue.
Okay. So now the question is,
sir, you can go a bit fast as well.
okay.
Yeah.
I can do that. Okay, then be ready for a little bit of roller coaster right now, but you will still understand. And you have now machine learning, you know what it is. Now you have categories within machine learning: supervised, unsupervised, and reinforcement. So what is supervised? A supervised is the table I have shown you, wherein it is driven by a task. You're given an input, you're predicting a number or a category. If you predict a number, it is called regression. If you're predicting a category, it's called classification. That's all it is. If you're predicting, hey, that's male, that is category. You're predicting, oh, the car in the front is 100 meters ahead of me. That is a value, number value. Okay. If you're predicting a number, that's called regression in machine learning. If you're predicting a category, it's called classification. Both come under supervised. In unsupervised, you are not really predicting. You are just understanding the behavior of the data inside the properties of the data. You are not given any examples of, oh, there is a male in this photo. Then the machine learns from their experience, from the data. And then, no, you're not given any clues about the data. The data is clueless, but it has its own internal properties within the data that using properties, you are deriving some insights. So that is unsupervised. Okay, there's no training in the sense that, hey, this is male photo, this is female photo. No, I'll give you a bunch of males and females. I don't tell you which one is male, which one is female. I don't tell you. You figure some commonality and then group them. Maybe it's this long hair as a property and say, I think all long hairs are together in a cluster. All short hairs are together in a cluster. It's try to learn based on the data without having any external supervision, and hence it's called unsupervised. External supervision comes with labeling of the class or getting that regression distance, but that won't happen in case of unsupervised. In supervised, that happens. So these are two different machine learning types. And then reinforcement is about trial and error, learn from mistakes. If you do good job, you get the reward. Otherwise, you get penalty, and then you keep exploring your environment until you do it right. So this is learn from mistakes. Okay. And there are 3 kinds. And then, so supervised learning always need to have the data labeled. Because the data is labeled, it gives you the direct feedback if you do something wrong. And then the objective of supervised learning is to predict that A to B, remember? The A to B models are everything is A to B in machine learning. You're predicting something, some outcome, or a value, or a future. In unsupervised learning, there is no label to the images given, or the spoken words, or given text. There are no labels. There's no feedback. Here there's a feedback because you're predicting something wrong, so there is a feedback. Here, what do you mean by predicting something wrong? But you find hidden structures inside the data. Okay. So this is more about how closely few different objects are connected. Whether they're close to each other or they are not. I mean, if they can be grouped into different groups or not. Reinforcement learning has to do with decision process, reward systems, and series of actions. And regression is simple. If you ask, hey, what's the temperature tomorrow? It's regression. Your ML is giving with an answer saying 84 degrees is regression. Hey, will it be cold or hot tomorrow? It's category. That's classification. Then you have a bunch of supervised learning models. And I don't want to get here. I also don't want to get here. I mean, this is simple. This is what it is. You're getting some data. This is data. Okay. And this data is labeled. What does that mean? Hey, this shape is nothing but rectangle. Hey, this shape is circle. So these are labels. If labels are given, the supervised learning. So the machine learns that hey, these shapes are these labels. It learns from that data, and then you have built a model. This is the program we talked about. Then unknown shape is given a triangle or a circle, a test data. At the test time, you're not giving that label, but it is predicting that label. This is simply a summary of machine learning and supervised learning. And there are many algorithms for supervised learning. If you hear these names, there are regression algorithms, there are classification algorithms that I am not worried to discuss. Unsupervised learning is about the two things that happen in unsupervised learning. Only two things. Either it is clustering or dimensionality reduction. What is dimensionality? Dimensions, number of dimensions you're reducing. What do you mean with number of dimensions? If you have a loan application, it has 26 fields. And 26 fields is too much of a math for us to do processing of 26 fields of 20,000 loan applications. That's too much for me to crunch numbers. Either anyway, I can translate those 26 numbers to meaningful short number. They are not 3 out of the 26. They are completely new combinations of dimensions. But I don't have 26 dimensions now. I only have 3 dimensions. Can 3 dimensions explain better? Then I would use only 3, means my computation is less. So dimensionality reduction is what you call. Okay. Here this is 3D, right? And then in this 3D, you have 3 dimensions, X, Y, Z. What if I project onto XY plane and then eliminate Z? So this is projection. Here you don't understand anything. Once you do the projection, once you do the dimensionality reduction, suddenly you could see some patterns. You just dropped one dimension. I'm just giving you, there are different ways to do dimensionality reduction. This is one way to do the dimensionality reduction, but there are many better ways that are PCA and all of that, wherein you are really transforming existing group of dimensions into a new set of dimensions, but then they are very small in count. If you have 10,000 fields in a given loan application, you would narrow that into 2, 3 different new dimensions that have something to do with these 10,000. And those 3 would be mostly explaining what the 10,000 fields in a loan application are doing. The job of these 10,000 fields in a loan application can be done by just 3 fields. So you're really reducing the dimensions. That's dimensional reduction. And then clustering is you're grouping them into different groups. So these are only 2 activities under unsupervised learning. And deep learning. What is deep learning? Deep learning is, in traditional machine learning, what you do is you extract features. Then you do a machine learning classification, regression algorithms on top of extracted features. In deep learning, you take raw data. You don't extract manually any features. Let the neural network with deep layers of mathematical components identify and then do its own learning. But you are not spoon feeding any features like in traditional machine learning. That's why the deep learning is different from machine learning, because in traditional deep learning, there is a bit intermediate step called extracting features, and then you classify those features or you do regression on top of it. In deep learning, we don't do that. In deep learning, we have artificial neural networks. These are logical mathematical structures. They call them as neurons. And if you see the traditional machine learning, you take the car and then you take the features like car, like some bumper or some kind of blobs out of this, and then you extract the features, then you send it to a classifier, then it says car or not car. This is not rule-based purely, but you're doing some help to the machine to extract the features, then do classification. In case of deep learning, there is no another step called feature extraction. It is part of the learning network itself. The features are extracted through the layers. Okay, high-level features versus low-level features. Initially, it learns the low-level features, then it learns, as we go deep in the network, high-level features. So this car 256 or 256, if you are just going to collapse or whatever, so you're having that inputs coming in, say this pixel data of each of these pixels is coming in, then you are having the next layer, some mathematical crunching is happening. This is simple mathematical crunching. Then you bring non-linearity by adding some non-linear functions. In other words, otherwise anything can be expressed as a as beta 1 x1 plus beta 2 x2 plus beta 3 x3. Versus can I bring some non-linearity to it? Those things you don't have to worry now. If you don't know deep learning, you would easily learn. But I just want to give you the basics of it. Also, this is deep learning, everybody knows. But then what is the difference between AI, machine learning, and deep learning? Deep learning is a subset of algorithms of machine learning algorithm, which is a superset. Machine learning is a subset of something called AI. So deep learning is a sub-discipline of machine learning. Machine learning is a sub-discipline of AI. This is a better way to understand. Because here, whatever algorithms in deep learning are part of machine learning. Not every machine learning algorithm is considered deep learning. Deep learning requires deep layers. Deep learning requires some kind of a neural network, some kind of a neural mechanism. There is not a, see, decision trees is part of machine learning, but decision tree is not part of deep learning. Okay, and anything to do with any of these things is part of AI. But if you're not using machine learning, if you're not using deep learning, if you're doing some rule-based work, remember that these are the two eyes or something. If you have some rule-based, and that is also loosely AI, but nobody likes to call or appreciate if you call the old traditional way of doing things as AI. You are also getting some intelligence out of it, but this is a very crude way you're getting. It's symbolic way of doing it, and this is non-symbolic way of doing it. Here, this is data-driven. Here, more sometimes you do rules, sometimes you do program-driven. Okay, and AI and data science. Then what is data science? Everybody's talking about AI and data science. What is the difference here? Data science is the whole life cycle, right from understanding the business problem and collecting the data, scraping the data if the data is on internet, or reaching out to somebody and then go to your data lake and then collect the data from data lake. Where do you collect the data from? What kind of data you need? And then once you collect the data, and you need to quickly explore whether this is the right data, complete, consistent, or coherent data. If not, then I need to do Tableau-based exploration of the data. Now I have done, this is the right data, I'm good to go. Now I still want to prepare the data for my model, because sometimes model want data to be normalized. Sometimes model wants to be consistent in terms of data, consistent, complete, and coherent. I want to make sure data is always consistently labeled. I want to make sure only these fields are captured every time. So consistency of data, completeness of the data, coherence of the data, that's data preparation. Then the modeling comes. Then after the modeling comes, you deploy it in the production, and then you get the feedback. So you have multiple steps. Within data science, all these steps are involved, right from business understanding. In AI, it's just generally bunch of models. So data science, if you look, what happens is you need to understand the domain, you need to understand big data, where the data is stored, you need to understand the business side of it, you need to understand how you get the data from that particular big data resource, and then you need to understand how you transform the data. But not only that, you need to see the data. Exploratory data analysis, EDA, is done with Tableau or any other visualization tools. So you need to have some kind of a visualization of the data before, and then you finally prepare the data. Once you prepare the data, which is also many times part of any AI work that you do. But in AI, you don't want to say big data is part of AI. You don't want to say domain knowledge is part of AI. You don't want to say acquiring data is part of AI. I mean, you're scraping from internet some data because you don't have readily available data. You need to scrape. No, for text analysis, you're scraping the Twitter data. No, that is input for your model, but it doesn't mean that acquiring the data is part of machine learning or part of AI. Transforming the data, well, you're doing some pre-processing. Data visualizations is Tableau. Tableau is not AI. So, but you may have to prepare the data to feed it to the model, either deep learning model, machine learning model, some other AI model. So to all these models, you need to prepare the data. After you evaluate the data, that preparation also could be part of the AI or also part of the data science. Now you see the distinction between these two. Now, what is AI, what is analytics, and what is optimization? I am already crossed my time, 8:07, and I can wrap it here. It's okay if you don't know all of it. It's okay if it is something you already know. But I do appreciate your time for this. Just in case if you have any questions. Anybody has any questions?
Thank you, sir. Thank you so much for your talk. I was having one question.
No.
It's not technical, but more on the entrepreneur side. So you have been an entrepreneur for decades now. So from your experience, one thing is that AI goes through these winters where for a decade it would be in very high demand, and then the demand would decline. And then again, after a few years, the demand would increase. So do you think that AI has become mature enough that we can skip this part of an AI winter?
There are three winters that happened from 1955, 56. The winter that happened is in the middle, that's by DARPA. DARPA has trusted CMU, Carnegie Mellon University, with $25 million. And then what they did during the Cold War, they gave the Russian documents to US. They wanted Russian documents. The US military wanted to translate the Russian secret documents into English, American English. So they thought some CMU language professors would be able to do that. Then they spend the money, and when it comes to doing the proof of the work that is being done, the translation was literally, remember, it is out of context translation. And so something very silly happened. I mean, I'm just giving you what could be I mean, if you do mucky to mucky translation, it doesn't make sense out of context. That's what it does. It didn't keep the context in mind, and they just pull the money off, saying that we spent 25 million in 1960s is a big money in those days, and then you have only achieved almost nothing. I mean, you don't understand the context in under which that particular statement, Russian statement, is given, and then you're translating that into something stupid. And um, so so that winter started there. Then again, a lot of heat has been built up in 80s and 90s, and then everybody started funding again that AI can kick up. That's when you have expert systems have taken a lot of role. Then they decided expert systems are too complicated, and then again funding stopped. When would research flourish? When funding comes. And the question for you is that, are we getting another winter in the next, if what if recession comes, markets go down? When investors tighten the funds, researchers don't have ability to go and use the funds to collect more and more data. Research staff don't have ability to hire more and more researchers, the academicians, and they cannot bring more. If you don't get fellowships, big fellowships, you don't do that research. You do where fellowships are paid. And who is paying the fellowships? Either the government or some private industry is paying for it because there's a demand for it. So my answer to you in simply is there is too much money in AI already. There are too many investors who are already committed, including the governments. Okay, so AI is just opening up. So we are not in that phase of closing down. Can closing down happen in 30, 50 years? Nobody can tell. But in the near to midterm future, AI is not going to go into midterm. Okay. And any other questions you guys have? In general? If you don't have, then I mean, maybe one thing I'll just quickly scan this. I mean, you know, the 4 kinds of analytics: descriptive, diagnostic, predictive, and prescriptive. I just want to let you know, prescriptive is the most automated way of doing analytics, and wherein predictive analytics means the moment you say predictive analytics, there is this blue line is automation, green line is human input. So in predictive world, would it rain tomorrow? You're predicting the weather. So obviously machine learning models can be used inside predictive analytics. But then there is some human input is also involved. But in prescriptive, under prescriptive, what should I do? You need to find there are multiple decisions. You know what? You know there is a chance that it's going to rain tomorrow. And then what are all the decisions you can take? The decision is cover the pitch. The decision is close the roof. The decision is everything has a cost involved. Closing the roof is very costly. Covering the pitch may not be. Or the decision is move the match to a closer to a smaller stadium. Means you are not letting all the audience. You are selectively randomly picking one among the 10 people who bought the tickets. The multiple decisions need to be made based on your prediction, and then what should you do now that this is going to happen, rain is going to come. What kind of prescription are you giving? You need to have, means there are multiple optimization solutions you have. So this decision automation is done using optimization here. So after you did the prediction using machine learning algorithm, what should you do is told by optimization. Okay, because you have multiple decisions you can make, but which is the optimal decision for you? Optimization comes there. So if you see this, the initial raw data, clean data, standard reports, all these things. Somebody gives you raw data, you clean the data, and then you do simple Power BI reporting and Excel reporting. That's nothing. That's ad hoc. There is OLAP. There's nothing. It's online analytical processing and programming. This is nothing. This is just simply slicing and dicing kind of reporting. Then what? No. We do a little bit higher end. Self-service BI, business intelligence you bring, some agility, some visualization, some Tableau, and some there could be some intelligence, and they show you why it did happen. Okay, what happened is simply reports. Why it happened is next level intelligence. No, I don't want you to tell me why it happened, but I want you to tell me, predict what happens, what will happen. Here, this is the box in which AI, ML, all of that would jump in. This is the hard part. I mean, this left side is not that hard. Your productivity really goes up if you bring in machine learning in productive analytics, predictive analytics. It's because when you go and take a job offer, you need to contrast. When they use the word analytics again and again, you need to understand this is how it happens in the real business. Okay, now I know what will happen. What should I do? That is prescriptive analytics. Here you do 10 possible actions. Which is the best action? You do optimization. You do some optimization techniques. Yeah, well, that could be generative algorithms, genetic algorithms. It could be swarm algorithms. There are multiple different optimization algorithms. You need to decide which was right. Is this a route planning situation? Which if it is going to rain, how do I deliver my Swiggy from point A to point B? Swiggy delivery. So your prediction is it's going to rain. Then what will happen? Are you going to delay your delivery? Then Swiggy loses its promise of delivering everything in 30 minutes. That is said. So what is the best route plan? Then optimization has to come. Okay, these are possible routes. Because it's raining, I need to find rain friendly. In other words, even if it rains, I should go fast. That kind of a routing, I need to reroute you. Optimization action is coming in. So these are real business problems. Until now, in the lab and in your experiments and your theory, you don't learn all of this. So analytics is very related to business and how you do business decisions based on the data and conditions, and then based on your predictions based on your AI/ML algorithms. Okay, I mean that's I just want to. Our AI for ICPS is the technology innovation hub. We are a Section 8 non-profit company, but we are a company. We are not an institute. We are owned by IIT Kharagpur, fully owned subsidiary. What does that? Which means we get the best of both worlds. We work like an industry. We want to take the research work from the industry, from the academia, whatever the thesis you generate, but we take it to commerce. We make products out of it. We support startups. So if any of you who is really into startups or want to be part of startups, let Raj know. Or you could just SMS me at my phone number. Write down. If you are already into startups or any of your student friends are into startups, IIT or non-IIT, if you want to be a startup, either you want to be a startup or you already know people who already have a startup, have them WhatsApp me. My number is 800 880 4440. 800 880 4440. I think we can end here. Thank you, everyone. Please do let me know if you have any AI startups that need some support, financial support, guidance support, or if you have an idea that you really want to make a startup, please, more than happy, because that's our number one thing. We want to support startups. We can fund anywhere from 3 lakhs to 1 crore, and we have funds in hand. But we will evaluate the startups. Only curated startups get selected. Even if you have an idea, we can support. But then you must be startup friendly. You must be willing to have a startup down the road. Just think of it, and please do. I'm just sharing in here my details. I mean, my email address is in the chat. My phone number is in the chat. Before we close in the next 1 minute, copy it and then reach out to me. If you have any startup idea, or you know a friend who has a startup, or you are thinking in the terms of I want to participate in a challenge, and then eventually whatever idea I come up with through those hackathons, internships in AI also we can do. So you can write to me if you are looking for AI internships. If you know any friend who is an AI engineer looking for a job, you can recommend him. We can probably hire. And if you're looking for funding for your startup, please do let me know. And I shared my data here in the chat. You must have copied. I think we are good now. Okay.
Thank you so much, sir, for your talk.
No problem.
Will it be okay if we take a screenshot, a photo with you?
Yeah, please.
So I would request everyone to please turn on your camera so that we can take a screenshot. So Deepak, please take the photo in a while, and after that, please let us know.
Yeah, so ready. Thank you.
Uh, yeah, thanks a lot, Deepak.
Okay, all the best.
So, sir, thanks a lot for your talk, and just a token of appreciation from our side. So, I will just share my screen. So, I hope my screen is visible. Yeah. So, sir, this is just a token of appreciation from us. So, this is a virtual meet. So, this token of appreciation has to be virtual as well. But of course, we will also be getting a physical memento from IEEE Kharagpur section soon. And with that, I would just like to thank you because the talk you gave, it's wonderful. The reason is that even if someone has experience with AI, for example, uh, they might be running a lot of deep learning models, but still don't know the basics. So this talk is good for them as well, even if they are in the AI. So it's just great. So thank you, sir. Thank you so much.
Thank you. Thank you. Good night.
Good night, everybody.
Thank you very much, sir.